Hey guys, in this lesson we're going to be taking a look at complement angle relationships as well as taking all of the trig functions that we've learned and mixing them together to solve problems. So to start off with, we'll start with talking about the complement angle relationships, and that is the trig functions that create the same ratio in a right triangle using both angles for the reference angle. So if we do an example of what that looks like, so given this right triangle here, they want us to name the given ratio in two different ways using our trig functions. So if we look, the first example says we're doing A over B. So using each of our reference angles, so we'll start with A and say it is our reference angle. We're looking at what A over B will be. So if we're looking at A as our reference angle, A is going to be the opposite over B is going to be our adjacent. So we want to think of which trig function uses opposite over adjacent with the reference angle of A. And if you have trouble remembering that, we've got the acronym that I talked to you a little bit about before, SOHCAHTOA. SOHCAHTOA is an acronym to help you remember the ratios that match up with each of the three main trig functions. And if you look, the three main trig functions are sine, cosine, and tangent. So what this acronym will do is sine of an angle is going to give you, you see the O, that stands for opposite over H, hypotenuse. And then the cosine of an angle is going to give you A's adjacent over hypotenuse for the H. And then the tangent of an angle is going to give us opposite over adjacent. And then from there you would just need to remember that what matches up with sine is the cosecant, and that's going to be hypotenuse over opposite. And then the one that matches up with cosine is secant, and it's the reciprocal, so hypotenuse over adjacent. And then tangent matches up with cotangent, adjacent over opposite. And these are just rules you're going to have to memorize. But if you remember SOHCAHTOA, that'll give you all that right there. And then sine matches up with cosecant, cosine matches up with secant, and tangent matches up with cotangent. So if we're using this rule, we're looking at, for angle A as our reference angle, we're looking at opposite over adjacent. So if we look at this list here, opposite over adjacent of an angle is going to be our tangent function. So the tangent of angle A is going to give us A over B. But that's not the only reference angle that we have there as an option. We also have B that we could use as a reference angle too, and we're still looking B for A over B. So if we look at the reference angle B, A is going to be the adjacent, and then B is going to be the opposite. So then we're looking through the rules for our trig functions, which trig function matches up with adjacent over opposite, and that's going to be the cotangent. So the cotangent of angle B for this triangle is going to give us A over B. If we try out the next one, they want us to do B over C. And if we try that for a reference angle A, B for reference angle A is going to be the adjacent over C, hypotenuse. So which trig function matches up with adjacent over hypotenuse? That's going to be the cosine. So the cosine of angle A is going to give us B over C. But that's not the only reference angle we have there. We also have angle B. So for B, we want to get the ratio B over C. And if we're looking at our reference angle as B, the side B is going to be our opposite over hypotenuse. So then we're looking for which trig function is opposite over hypotenuse. And that's going to be the sine of angle B is going to give us opposite over hypotenuse. And then looking at the last example that we have, we're doing C over A. So if we do C over A, we want to do it for both reference angles. So A is going to be equal to C over A. And for angle A, C is the hypotenuse. And then A is going to be the opposite. So we're looking for hypotenuse over opposite, and that's going to be the cosecant of A is going to give us C over A. We need to do it for the other reference angle as well, so we've got to look at B. So then B, we want the ratio to be C over A. And looking at angle B, C is going to be the hypotenuse. And then the A is going to be the adjacent. So if we look at the list for hypotenuse over adjacent, that's going to be our secant. So cosecant of A is going to be equal to C over A, and the secant of B is going to be equal to C over A. And so that's what it looks like whenever you take these complement angle relationships and set up the ratios and be able to solve. The big thing is to look at the ratio, write down what sides you have, for the reference angle. And then match up the trig function. We can also use the SOHCAHTOA rules to solve for sides. And this is just like we did before when we did the sections individually and we did the tangent and then we did the sine and then we did the cosine, but now it's going to be mixed all together and you're going to need to decide which one you're going to be using. So if we look at this first one, our reference angle, the directions say determine the trig ratio that you would use to solve for x, explain y, and then solve for x. So if we look at this one, right here's our reference angle. We know it is because they give us an angle measure. So then according to this one, this is going to be our opposite, and this one's going to be our hypotenuse. Hypotenuse is always across from 90, and that's directly across. So if we're solving, we're wanting to use one of the three main trig functions because those are really easy to enter in our calculator. If we wanted to do secant, cosecant, or cotangent, we could, but we would have to do 1 over and do the math that way. With these, we can just enter them straight as you see them. So we're going to want to stick with using these. So we're looking for which trig function uses opposite and hypotenuse. So that's going to be sine. So determine the trig ratio that we're going to use. We're going to use sine. We're given opposite and hypotenuse. And then it says solve. So I'm going to write the rule. The sine of an angle is going to be equal to opposite over hypotenuse. So the sine of our angle in this case is 35 degrees is going to be equal to our opposite is x over the hypotenuse is going to be 8. So to solve for x, we multiply both sides by the denominator. So we end up with 8 sine of 35 is going to give us our x. And if we put that into the calculator, 8 sine 35, I'm going to double check what mode I'm in. It's in radians, So I need to switch it and double check and make sure I'm in degrees. So I switched to degrees, go and quit out. There we go. So x is going to be equal to 4.59, and our units are centimeters. And I'm going to round to the nearest hundredth. Looking at the next one, here's our reference angle right there. It's 20. Here's the hypotenuse. Here's the opposite, and there's the adjacent. So we're looking for a trig function that has us use hypotenuse and adjacent. So if you look up across our list, cosine. So we're going to use cosine because we are given the adjacent and the opposite. And it wants us to solve it out. So if we solve it out, I'm going to write the rule. Cosine of an angle is going to be equal to adjacent over hypotenuse. So cosine, and the angle that we're working with is 20, is going to be equal to the adjacent is going to be 15 over the hypotenuse is x. So we're solving for x. So multiply both sides by the denominator when you've got a fraction. That'll leave us with x times the cosine of 20 degrees is going to be equal to 15. X isn't all by itself on one side, the equal sign. So I'm going to divide both sides by what I need to move, the cosine of 20. And if we put that into the calculator, 15 divided by cosine of 20 is going to give us x is equal to 15.96, and our units are meters. So the length of that hypotenuse is going to be 15.96 meters. And looking at the last example, there's the reference angle. This one's the hypotenuse. This one's the opposite. That makes this one be the adjacent. And the sides that they actually give us values for are that one and that one. So we're looking for which trig function uses opposite and adjacent. And that one's going to be, it says, determine which trig ratio, so tangent. And it says explain why. It's because we're given opposite and adjacent, and then solve. So that means we need to use the tangent rule. The tangent of an angle is going to be equal to opposite over adjacent. So we plug in the values that we have and solve for the ones that we don't. So tangent of an angle is 20 degrees. The angle we're working with is 20. Is going to be equal to opposite, which is 15, over adjacent, which is x. Solve for x, we need to multiply both sides by the denominator. So then x times the tangent of 20 is going to give us 15. X is not all by itself, so we've got to divide both sides by the tangent of 20. So 15 divided by tangent of 20. So x is going to give you 41.21, and our units are meters. Looking at the next one, looking at this one, they give us both sides, but in the directions it says to solve for x. So if we look at these problem, x is right there. X is an angle. So since we're solving for an angle, I know automatically I'm going to use an inverse function. So then we need to figure out which one. If this is our reference angle, well, there's our hypotenuse, here's the opposite, and there's the adjacent. So we're still thinking, which trig function uses opposite and adjacent? That's going to be tangent, but we're going to be using the inverse tangent. So we're going to use inverse tangent because we're solving for an angle. And they they give us opposite and adjacent. So I'm going to use the inverse tangent function. The inverse tangent of opposite over adjacent is going to give us our angle x. So if we solve that out, the inverse tangent, the opposite is 49 over 15 will give us angle x. So to type in inverse tangent, second tangent, you should see the inverse tangent pop up on your calculator. 49 divided by 15. So angle x is going to be equal to 72.98 degrees. Looking at the next one, there's no x on a side here, but there's an x there. So that means we're solving for an angle again. We're still using an inverse function. So I'm going to go ahead and start that we're going to use an inverse. But we need to figure out inverse of which one. So this one's opposite. This one's hypotenuse. That's the right angle right there, which makes this one be the adjacent. But these are the only two they give us values for. So which trig function uses opposite and hypotenuse? It's going to be the sine. So we're going to use the inverse sine. We're solving for an angle. And we're given opposite and hypotenuse. I'm going to write given there. Okay, so the inverse sine of opposite over hypotenuse is going to give us our angle x. So the inverse sine, our opposite is 4 square root of 3 over 8 will give us angle x. So if we put that in the calculator, the inverse sine, and I'm going to put the 4 square root of 3 in parentheses by itself, divided by 8, and then close the parentheses. That way 4/3 is all 1, and then divided by 8. We only need one parenthesis there. No, we needed both of them. So there we go, both of them. So to close the 3 in, and then the second set to put the 4/3 together. And that'll give us our angle x is going to be equal to 60 degrees. Looking at the last one, again, we're solving for an angle, which means we're going to use an inverse. But inverse which one? Here's the hypotenuse. This one's going to be opposite. This one's going to be adjacent. So we're looking for a trig function that uses adjacent and hypotenuse. And that's going to be the cosine. And we're using the inverse cosine because we're solving for an angle. And we're given the adjacent and the hypotenuse. Okay. So to solve for x, the inverse cosine of adjacent over hypotenuse is going to give us angle x. So the inverse cosine, the adjacent is 4 over 12, will give us angle x. So inverse cosine, 4 over 12. So angle x is going to be approximately 70.53 degrees. So there's how to, when you're given a triangle, to either solve for the side using all 3 of the different trig functions, or to solve for an angle using all 3 of the different trig functions. They could also give you word problems to solve. And when they're giving you word problems, there's 2 big phrases that they could use. They could give you angle of elevation to solve for, or they can give you angle of depression. When you're looking at angle of elevation, it's the angle between looking straight ahead, so just like you were looking straight ahead, so looking straight ahead, or the ground, depending on what's going on in the problem, and looking up. So if this person were to look straight up, this angle right here, that would be the angle of elevation. And so if you draw a straight line right there, there's your 90-degree angle, and that what makes it be a trig function using the sine, cosine, or tangent. And the way I look at it is whenever it's an angle of elevation, it's going to be a hypotenuse of triangle. So there's your hypotenuse, and it's facing up instead of being upside down. So if we try one out, this example said that you are standing at 40 feet away from a building. So with these, the big thing is to be drawing pictures. So there's a building, and you're standing 40 feet away. The angle of elevation from the ground, so from there to the top of the building, is 57 degrees. So that means straight out right ahead, there's your 90-degree angle. What is the height of the building? So height, how tall the building is right there, we don't know. So we make that be x. And it says we're standing 40 feet away. So there's our 40. So from here, we need to figure out which trig function we're going to use to do this. So if we look, here's the reference angle. That's the one they gave us information for. Here's the hypotenuse. This one's going to be opposite, and this one's going to be adjacent. So the trig function that uses opposite and adjacent, that's going to be the tangent. I'm going to write the definition. Tangent of an angle is going to be equal to opposite over adjacent. So tangent of 57 degrees is going to be equal to the opposite of x. The adjacent is 40. So we need to solve for x. So we're going to multiply both sides by the denominator. So 40 times the tangent of 57 is going to give us the height of the building. So 40 tangent 57. So the building is going to be 61.59, and our units from the word problem are going to be feet. So the only thing this really adds is you have to know the angle of elevation means from looking straight ahead to looking up. The rest is just drawing a picture for what they describe and then figuring out which trig function you need. So if you wanted steps 1, draw picture. And then 2, label picture. And 3, you're going to have to determine the sides and what trig function. And then solve. And that's going to be the same thing that you're going to do for these problems down here, only here we're looking at the angle of depression. So the angle of depression is going to be the angle between looking straight ahead or being straight ahead and looking down. So if this person were to look down, there's the angle of depression right there. And then there's the right triangle there. So there's the hypotenuse. So see what I mean about it being a hypotenuse down triangle? The hypotenuse is on the bottom side. And it looks like an upside down triangle.